So, okay, okay, sir, sure, I'll deal with this. The connectivity you're saying about the notations as well as because different books have different notations. So no issue. We'll deal and let us see the participants. There are still only 8 participants have come. So s- many people are joining. So wait for 5 minutes. I'll request you. So exact at 6:05 we will start this session. So stay tuned till now. Tejashvi, there is a request. Can you please mute your voice? If you have query, please ask. Okay, I'm muting from my side. Okay, so we should start now. So a basic instruction for all whoever will have a query, please raise your hand first. Then I'll hear your query and answer. And a small suggestion for all those who cannot join or there is some network issue or any kind of stuff. So I will record this video and I'll post in my YouTube channel as per of the rules. So here is my YouTube channel. In the chat, I have mentioned it. So I'll start now. So there's still 12 participants. No issue. Please raise your hand before asking question. So here in this live session, this is an interactive live session for week 1. So in this live session I will be dealing with the concepts of the week one contents, as well as some of the questions which will help you in solving the assignment questions. So before going to the content of this live session, the content of this live session, I try to capture the basic concepts of the communication system. The communication system itself starts from the amplitude modulation and analog modulation. Amplitude modulation comes under analog modulation. There are two types of modulation, which is analog and digital. So here the amplitude in this course you will be dealing with mostly the analog modulation and its concepts. So amplitude modulation, here you will have the fundamental and oldest technique of analog modulation, and here the amplitude of the carrier wave which is transmitting the which is a carrier along with the modulating signal message signal which transmits along with the modulating signals, it is varied in proportion to the waveform being transmitted. So, and similarly, we'll have the frequency modulation. The frequency modulation, you will have the frequency of the carrier will be uh, varied in proportional to the waveform being transmitted. And a waveform here, the message signal, the message which is carrying the actual information. The communication here means the transfer of the information from one to another location. So similarly, the concept of sampling comes. So here, then we are going to the aim of the course. So this particular course of Principle of Communication System 1 is focused on the fundamental principle of communication. Those who are willing to learn the communication, which will introduce the students the fundamental concepts very clearly, line by line, as well as in a simple fashion, and it will bridge the gap between communication theory and the application. So it will also helps in the foundation for the study of the advanced communication system and applications in communication systems such as 3G, 4G, and 5G. So let us go through that. So first, in the first module, you will have the keywords as the energy of a signal, power of a signal, and periodic signal. So I will first let you know what is energy of the signal. The energy of the signal is defined as Ex is equals to minus infinity to infinity integral of mod of xt square into dt. So here the xt can be any signal. So moving ahead, if we take the example of xt is equals to e to power minus t, and along with defined with the ut is the unit function which is defined for t greater than 0. Ut is equals to some amplitude. For here we are taken as 1, you can see, or for t greater than equal to 0, otherwise it will be 0. So this is a unit step function, and if you are asked to calculate the energy of xt is equals to this one, so how will you calculate? In some of the questions you might have the assignment questions related to this. So xt square dt, so here ut e to power minus t ka square into dt, and since ut here the ut is also there with xt, so it will be from 0 to infinity, because we can see the amplitude is equals to 1 for t greater than equal to 0 only. So so e to power minus 2t dt, then e to power minus 2t divided by minus 2, 0 to infinity, then e to power minus 1 by 2 if you taken out, then e to power minus infinity minus e to power 0, then what is e to power minus infinity is equals to 1, then equals to 0 minus 1 and minus 1 by 2, and then minus 1 into 1 by 2 is equals to 1, 1 by 2. So here e to power 0 is equals to 1 and e to power minus infinity is equals to 0. So in this way you can calculate the energy of any signal. And the question arises, energy of a signal is defined for an energy signal. And how the energy signal is defined for any signal, if the energy is positive, positive or negative, doesn't matter. If the finite, then the signal will be called as energy signal. So this signal will be called as energy signal. Since this energy will be finite, then it will be called as energy signal. Similarly, what is the power of a signal? The power of a signal is defined as the formula of limit t tends to infinity 1 by t, uh, integration of minus t by 2 to t by 2 mod of t xt square dt. So as KG Krishna sir was asking about this t, the notation t and a tilde, some in some of the books the t tilde here refers as a period of the signal. Some book may refer as t average, some book may refer just as a t, and other notations are already also there. So since the power of a signal is defined for a periodic signal, so because since periodic signal itself repeats after a finite time interval, so we only calculate for this the interval and just let the t to tends to infinity, so that we can calculate the energy or the power content in this signal. For the periodic signal, the energy is called as a power for the signal, and here the power signal. Now the question arises, the how can we define the power of a signal? So power of a signal is defined using this formula, and how can we discriminate between power and energy signal is using the finite formula or the finite concept. So as I told you about the energy signal, the energy signal is called as energy signal if the energy of any signal is finite, and the power signal is called the power signal if the power of any periodic signal is finite. So for example, if we can take any power of power, calculating power of any signal, we can calculate. So moving ahead, um, the question arises, I will ask you the question about how can you calculate the power of an energy signal and energy of a power signal. So this question I'll deal with you in the question answer section. So moving ahead, how can you calculate the period of a signal? What is period? So a signal, if it is a signal which repeats after a certain period, then the certain period itself here is the period of the signal. So how can we define it? So the periodic signal has only the periods. So for example, this is the signal sine 2 pi f t plus kt. So here we can see this this t plus kt. If we calculate sine 2 pi ft plus 2 pi fkt, then we can see this 2 pi k itself has the itself has the repetition. So itself has the repetition. So how can you calculate the power, the period for this? So period is equals to 2 pi by omega. And here 2 omega itself is a 2 pi f. So t is equals to 2 pi by 2 pi f. Then 1 by f. So here you are having the period of 1 by f. Then moving ahead, the power of a periodic signal, we know that it is defined as this one, limit t tends to infinity 1 by t, integration of minus t by 2 to t by 2 mod of xt square dt. So here if we know the periodic signal, then we know that t tilde will be m into t, where m is an integer. So when m tends to infinity, t also tends to infinity. So here we are defining it as a limit t tends to infinity. Then moving ahead for the next power and periodic and the energy signal we get to know, we will solve questions related to this. And if we go to the next module, which is the frequency domain representation and introduction to discrete Fourier series. So who are not from this background, may not know about the Fourier series and the frequency domain representation, and why even we know, need to convert the time domain signal to a frequency domain signal. So the conversion is very important and it is required because we are required to calculate the bandwidth of a particular signal, because bandwidth is very expensive, and that we are also having a particular spectrum for particular use case. So we are required to calculate the bandwidth, as well as some of the computation which are very calculative in time domain becomes very easy in the frequency domain. So let's calculate the frequency domain representation of this signal, and how the problem of discrete Fourier series comes. The frequency domain representation is a fundamental tools for communication, and which is required for calculate the spectrum, which is also known as bandwidth. So if we see the spectrum, we can calculate in the form of two parts. First one is the Fourier series, and the second one is the Fourier transform. The Fourier series, it is discrete in frequency. Discrete means we can actually make a discrete in terms of the numbers 1, 2, 3, and 4. Whereas in Fourier transform itself is a very continuous in frequency. Continuous means here you cannot define the value of any amplitude with respect to frequency. Here it will have the continuous waveform. So this is termed as a frequency domain signal representation, also as the spectrum of the signal. And here in the communication, everyone is actually running for the spectrum, and the spectrum is very expensive. So we have to save it to have a proper communication. And further, the spectrum can be of two types. One is the Fourier series, which is discrete in frequency. Uh, yeah, Tejasvi, hello. Are you speaking anything? Those who have any doubts, please first raise hand, then please ask, or you can also ask in the chat box. In the next, after dealing with the concepts, we will solve the questions related to some of the assignments questions. So stay tuned. So okay. So I what I was saying about the frequency domain representation, which is discrete in frequency and the continuous in frequency. Discrete in frequency is called the Fourier series, and the continuous in frequency is called Fourier transform. So how can you write the Fourier series? Uh, the Fourier series is defined for a periodic signal. Consider xt to be a periodic signal which period with period t. Then how can you calculate the Fourier series? So the Fourier series can be of many types. First one is the exponential Fourier series, and the exponential Fourier series defined as the xt is equals to summation of k is equals to minus infinity to infinity ck e to power j 2 pi k f naught t. Here f naught is the fundamental frequency of the periodic signal. As I told, this is defined for the periodic signal, only for periodic signal. Then f naught is equals to 1 by t, and t is a time period. Then how the ck can be defined? The uh, ck is a complex exponential term. So the Aditya sir must have taught you in the class how the ck can be defined, and ck is equals to 1 by t minus t by 2. So t by 2 minus t by 2 to t by 2 summation of minus t by 2 to t by 2 integral of xt. This one is the ck e to power minus j 2 pi l f naught t, and here the subscription is l is written. So ck you can also write here in place of l, you can write k. So if we write the exponential Fourier series, then is equals to summation of ck e to power minus e to power j 2 pi k f naught t, and ck here it is defined as here like this. So moving to the next Fourier series representation, which is in the form of A and B. So first we will tell the orthogonal property of the CK. So the orthogonal property means the summation integration of minus infinity to infinity ft into f dash t is equals to 0. So if f and f dash is satisfied, then it will be orthogonal. Orthogonal means this will be having some properties of orthogonal, like sine and cos. If we multiply and integrate it, then it will be 0. So, how can you specify the orthogonal property of particular signal? Then, if we are defining using a energy of the signal, if the energy of a signal is 0, then that particular signal is itself a orthogonal signal. So, CK here satisfy as an orthogonal property. So, here CL we define as the Lth coefficient in the discrete Fourier series representation of the periodic signal. So moving ahead, the discrete Fourier series example and a Parseval theorem for the periodic series. So let us see this. This is a xt signal with time t, and you are having the amplitude of a if t lies between 0 to d. And again, this signal repeats from this particular part to this particular part. The signal repeats. So this is the time period t. So how you can define d? D is equals to t by 4, for example. Then how let us calculate the CK exponential Fourier series coefficient, exponential Fourier series coefficient, and then the Fourier series representation of xt. So if we calculate the exponential Fourier series coefficient using the formula mentioned, so it is 1 by t integration of minus t by 2, so t by 2 xt e to power minus j 2 pi L f naught t. So here we know f naught is what? F naught is equals to 1 by t. And we know t is equals to t by 4. Sorry, t is equals to 4d. T is equals to 4d. The f naught is equals to 1 by 4d. So if we calculate and put it in the formula of this, you will get the Cn and the sim and the corresponding xt. So here the Fourier series is represented as like this. And if we calculate the CL, then it can be over any period of xt, that is from t to t plus 2. T plus capital T, and here the capital T is the period of the signal. So moving ahead, how you can calculate the CL? So I told you T here, the T by 4. Then since signal is non-zero only for 0 to T by 4. So here T can be represented as T by 4. So that it will be non-zero. Then if we calculate, then it will be CL is equals to this one, and C0 is equals to A by 4. Similarly, you can calculate C1, C2 for putting in the formula of xt is equals to summation of k is equals to minus infinity to infinity ck e to power j 2 by k f naught t. You will have to calculate C1, C2 because here the summation is this. So C naught is equals to A by 4. And if L is equals to not equal to 0, how can reformulate in form of mathematics? It is the formulation of that. These all things are being taught by you by Aditya sir in the class. I'm just going through the for recapitulation of your concept so that we can solve some questions related to this. So A e to power A j 2 pi L. So in the slide time 16:8, if we refer, then the sir has calculated CL is equals to A by pi L sine pi L by 4 e to the power minus j pi L by 4. Then he has written the form of L is equals to 0 or not equals to 0, how it will be represented. These are all required for calculating a Fourier series. So these are all about the Fourier series. And one more important thing is so you all get to know about this Fourier series representation. Okay, so then the question might have arise about what is the property of ck and how it is helpful. So that again the theorem comes, which is the Parseval energy theorem. So in the Parseval energy theorem or the Parseval power theorem, in the power theorem, why power? Because it is defined for the periodic signal. So the Parseval power theorem is defined using Ck, which is exponential Fourier series coefficient, and that the power of a signal xt is equals to the summation of Ck minus infinity to infinity. And here we will prove how it is. So let us calculate the conjugate of the signal xt. So the conjugate will be only the negative of this minus j, and then you can calculate the conjugate, and the conjugate will be this. Then how can calculate the power? So I told you the formula of the power, which is minus t to t 1 by t minus t by 2 to t by 2 um, mod of xt ka square dt. So mod of xt can also be written as xt into x conjugate of t for a complex signal. For a complex periodic signal. Periodic signal. So similar way we have done this. How you can calculate the power. The power is equal to similar to xt and similarly e to the power minus j 2 pi k f naught t. And just multiply this, how we'll get. Here you will get just 1, because e to the power 0 you will get. And the ck into c to the power minus k. And let us solve here only. T 0 to t, k is minus infinity to infinity, ck into cn k star, and here's e to the power j 2 pi k f naught t into minus j 2 pi k f naught t. Here m. So it is this. How we can further simplify it? So by further simplifying it, these terms are the common term, and this one k minus m, because for different conjugate we can have a different cm, right? The c k might not be equals to cm, because cm is defined for conjugate of xt, whereas ck is defined for the xt only. So here you have to take care for this. So this is the final power calculated for a complex signal xt. So now we have to expand this in order to calculate the power using ck only. So how can you expand? So if we take the term out, which is this one, then integration, it will be happening over this one 1 by t 0 to t e to the power j k minus m f naught t, which can we can write del of k minus m. So here you might not aware of the Fourier transform yet, but I'll deal with how this is equal to del k minus m. This is related to the Fourier transform. So it is a Fourier transform of del k minus m. So we here the del k minus m, it will equals to m if k is equals to m, because the property of a delta function. So do you know the property of delta function? I'll just let you know. T del t. So del t is the delta function, which we also say as Dirichlet delta function. Let me reduce the width of this one. Dirichlet delta function. And it is equals to infinity at t is equals to 0, whereas 0, infinity I can represent like this, t not equals to 0. So similarly, if we can shift the signal, if we know the basic properties of the signal, if we shift the signal using del t minus m, where we will have now infinity term will happen as t is equals to m. So del t minus m is equals to infinity at t is equals to m, whereas 0 at t is equals to not m. But it is defined for the continuous signal. Now for the discrete signal, these infinity values will be equals to 1. So for here we are considering for the discrete signal. So similarly, I told you about k is equals to m is equals to 1, otherwise it will be 0. So for the n, for the discrete time period, we represent t as k, m, n, anything. But here not t. T is representing as a continuous signal. So sir has written this k, then it will be equals to 1 and k minus m. So this is the representation of this. So if we further simplify it, then it will be equals to 1 and when k is equals to m, and just we are putting this k is equals to m here, and the only summation will have only one summations, then is equals to ck into ck star, then this modulus of ck square. So this power now is equals to summation of minus infinity to infinity mod of ck square. K is equals to infinity. And this power is defined as 1 by t integration of minus t by 2 to t by 2 mod of xt square dt. So this is known as Parseval power theorem. Using your Fourier series, you are representing the signal in the form of the summation of the sine, cosine, as well as exponential terms. So using Fourier series, you are representing xt is equals to ck e to power minus j e to power sorry plus j. In ck you will have minus, in overall term you will have only plus e to power j 2 pi k f naught t, and here using only your ck exponential Fourier series coefficient, you are representing the power of the signal, and the power itself is equals to summation of minus infinity to infinity mod of ck square. Okay, so this is a Parseval power theorem, and we can have any question related to this. May you might be able to solve now. So this is a Parseval theorem which I told now just now, here the mathematical representation, and how the Parseval theorem is useful. It is helps to find the distribution of power among various spectral component. So here using this Fourier series, we are able to calculate discrete spectrum, right? I told you earlier. And now the average power C1, C2, C3 in every frequency component f naught, 2f naught, and 3f naught. So it helps to find the distribution of power among various spectral components and the power in terms of the spectrum. So this is actually the power in terms of spectrum. So moving ahead, this is all about the Parseval power theorem. And this one is a module 1 only, lecture 4, which was sir was talking about the Fourier transform, inverse Fourier transform of continuous signal, example of Fourier transform of pulse and the sine function. And I'll deal with the questions, how you can solve the questions related to this also. So, welcome, and here in this Fourier transform, how we can define the Fourier transform? The Fourier transform is defined for the continuous periodic signal. So, continuous signals we can define for the Fourier transform, and how you can define using mathematical formulation. So, uh, x is equals to minus infinity to infinity xt e to the power minus j 2 pi ft. So here it is the Fourier transform. And here the Fourier transform can also be defined for the aperiodic signal. So difference between Fourier series and Fourier transform, everybody can ask you. The Fourier series was only for periodic discrete signals. Here it can continuous or periodic signal. So if we consider the aperiodic signal xt, is Fourier transform xr is defined as given as minus infinity to infinity xt e to the power minus j 2 pi ft. So moving ahead, this is the Fourier transform and the time domain. Here you should remember this is the frequency domain, and frequency domain is very important, I told you earlier. So moving ahead, so in Fourier transform you will have the two properties. As we defined, xf is equals to minus infinity to infinity xt e to the power minus j 2 pi ft dt. So xf will have two property: magnitude, spectrum. This is all about the spectrum only and the phase spectrum. So here we will define the magnitude spectrum and phase spectrum using an example. So let us first, before going to the example, let us define inverse Fourier transform also. So inverse Fourier transform, how you can calculate the inverse Fourier transform? If we have the spectrum in the frequency domain, then xt is equals to minus infinity to infinity xf e to the power j 2 pi ft. And this is inverse Fourier transform. It is also useful for some scenarios. And in your assignments, in your final exam as well, you may ask to solve the to calculate the inverse Fourier transform of many signals. So please remember these two formulas. Then only you will be able to get the actual degree of this course. So let us, for example, take the function ut. Sorry, pulse function. Pulse function. The pulse function is defined for a particular period, and it is equals to 1 because it is similar in looking to the as pulse. It is also called rectangular function somewhere in the book function, and it is also defined using RT. Here the sir has written PT. So PT is equals to 1 if mod of t less than equals to t by 2, otherwise it is equals to 0. So here this mod of t less than equals to t by 2 means, sorry, here I'll write t less than equals to t by 2, whereas minus t less than equals to greater than equals to t by 2. Similar properties of modulus function. So here 1 if these two criteria satisfy. So 1 if it is here, and minus t if it is greater than minus t by 2 here. So how you can calculate the Fourier transform of that? So just you have to put the values in this. So we know that 0 to t by 2 it is 1 e comma minus j 2 pi f t dt, and if it is minus t by 2 to 0, then it equals to 1 the minus j 2 pi f t dt. Then how will calculate this one? Let us calculate here only. So minus j 2 pi f t equal minus j 2 pi f j 2 pi f 0 to t by 2. Then again this similar one, so power minus j 2 pi f t equal power minus j 2 pi f minus t by 2 say t. And if you put the value equal power minus j 2 pi f t by 2 minus j 2 pi f and here minus 1, then plus 1 minus e to power j minus ft by 2 plus, because here minus 1 will come with a plus, here minus j 2 pi f. Further solving, this is 1 equals to 0. Then if you take minus j 2 pi f out, then e to power minus j 2 pi f t by 2 minus e to power j 2 pi f t by 2. So this is here written in the simplified way. Here, here it is written in simplified way. Here I told you xf, because pf was taken, then p of f transformed in pt of f. Because pt of time domain it was returning, then in frequency domain it is pf. So this one I calculated simplified in the above equations. Then how you can further calculate this? So you know sine t, you can write x of t minus x of t minus t divided by 2j. It is an exponential representation of sine function. And for the cosine, you will just have plus and j will not be there. But here we are taking about sine t. So further, this is similar to that. Then we can calculate this, since plus should be there. Then minus 2j came, because 2j just here you can put, and then similarly e to power minus t plus t, here you just take this as a t, then here 2 by ft by 2, here you are getting t. So you are getting as a simplified version as this one, pt of f is equals to sine of pi f t pi f. So I'll tell you one formulation of this sine pi t divided by pi t. So you can further write this in sine pi f t divided by pi f t and t. So you can further write this t into sinc of ft. And this is the sinc function. In the 4 years, in your upcoming course, you will be very much familiar with this sync function, because we usually transmit sync function in the Fourier series in the frequency domain as well as the time domain, because you are having, yeah. Anybody was having doubt? Somebody raised a voice hand. Okay. If you have any doubt, then please do write in the chat box. So again, I'm starting. So this sync function is very important. It is where it is being used everywhere to transmit the signal, either in the form of time domain as well as a frequency domain. So we calculate the Fourier transform of pulse signal in the form of this particular function, and we also calculate this is equals to t sync of ft. Please do remember this formulation. The Fourier transform of pulse signal is a sync function. Please do remember. And it has some properties, I'll let you know. So this is the what I was telling. This pulse function you have pt of t, and you are having pt of f. So this is a pt of f is equals to 2 sync t sync ft. So let us see some of the properties of sync function. How we can calculate the sync of 0? Then sync of 0, we can just let it as limit is extends to 0, sync of pi x. Then sync of x is equals to pi x divided by pi x. Then this one is equals to 1. You all know. Then sync of 0 is equals to 1. Similarly, sync of x and also sync of pi x is equals to 0 if it's, you know about this. Sync of pi x is equals to 0. This implies pi x is equals to k pi, because at every interval of a sine function of the multiple of the pi, the sine function will be 0. Sine x, and this is x. So sine of pi is equals to 0, sine of 2 pi is equals to 0, sine of 3 pi is equals to 0. So here you can write like this. Then how you can formulate a property of the sink here? The p of t of f is equals to t sink ft. Then if f is equals to 0, then it is equals to 0. And if f is equals to k by t, then it will be t sink k, and it is equals to 0. So we can further write this. It looks like a sine x, except the amplitude is going to be decreasing due to 1 by f. So sink of x is equals to x equals to s. It is decreasing in amplitude. And it equals to what it should be. Can somebody answer in the chat box? 1 by f, 2 by f, 3 by f. Integer multiple of k by f. And the k here the integer. So moving ahead, see, this is a T sync FT, and this particular frequency is also called the nulls. So 1 by T is equals to null, one null, 1 by 2, 1, 2 by T is equals to second null. Sorry, I was telling about the frequency domain here. So here should be T, because the frequency we can also can't write in the form of frequency itself. So here it is called the null. And the first occurring null, between the negative first occurring null and the positive first occurring null, there's a bandwidth defined, which is null to null bandwidth. So null to null bandwidth for the sync function is 2 by t. So it is null to null bandwidth is 2 by t. So Fourier transform of a pulse signal is a T sync ft, and we are having with the null to null bandwidth of 2 by t. Similarly, we will calculate some of the other frequency domain of some other functions. This sync function is very important because it has some properties of following as a transmitted pulse. And since it is decreasing in magnitude, because we usually have in communication system, the main magnitude occurs at in but in some up to some frequency domain, some frequency bandwidth only, because after that it should be decreasing in nature, so that once we transmit it through a linear system, then after that the actual information shouldn't be lost, so we can use the filter and we can use only this particular part. So here, modulation property of Fourier transform, direct delta, unit impulse, and the Fourier transform. So if we see this modulation property, so the question arises in the first slide. I just let you know what the amplitude modulation. Amplitude modulation is a part of analog modulation, and we usually have two modulation: analog and digital modulation. In analog modulation, we have amplitude modulation, frequency modulation, and phase modulation. So just before going that, I'll I'll just write here modulation. In communication system, we have modulation, and modulation we have analog, digital. In analog, you have amplitude, frequency, and phase modulation. So the modulation is defined using this particular term. Like we are trying to convert the small frequency to a large frequency so that we can transmit over a large distance, and we are modulating a frequency of a signal, and that modulation can occur at the point of amplitude, phase and frequency. The modulation simply refers to the operation, that is this operation, that is which is xt multiplied with a complex sinusoidal with very high frequency. And in fact, it is one of the most fundamental principle of communication. And if xt is your signal and x delta t is your term as a modulated signal, and this process is called the modulation. And here, when we modulate it, we are employing a complex sinusoid. In general, we employ a real signal, that is either a cosine or sine. And xt is multiplied by e to the power j 2 pi fct, which is carrier frequency is fct. So, how can you calculate the Fourier transform of this? So after the modulation, this signal will be x tilde of t, x tilde of t. Then x tilde of t, x tilde of f. Fourier transform will be x tilde of. How you can calculate the Fourier transform of this? Using the simple property of the Fourier transform, this which is x tilde of f is equals to minus infinity to infinity x tilde of t e to the power minus j 2 pi f t dt. And if you just put the value of x tilde of t, and we just know by above equation, this one, equation 1, equation 1 from, then x of t equal j 2 pi f c t equal minus j 2 pi f t dt. So this one is a modulated frequency, Fourier transform of modulated signal xt. So this one is, if we further simplify that one, minus infinity to infinity x of t e to the power j 2 pi f t plus j 2 pi f c t dt. This comes from modulation. This comes from Fourier transform formula. Then minus infinity to infinity x of t, we can just take e to the power j 2 pi f e to the power j 2 pi f of minus fc dt, here minus 1 e to the power j, he from Fourier transform formula, then you will get this one. And this one is simply for the frequency shifting. And if you just relate with the Fourier transform formula, then it is simply x tilde of f is equals to x of f minus fc. So what you're doing here, you are having the time domain signal xt, sorry, the frequency domain x of f. Then you are just shifting it to f of fc x of. So this is the modulation. So this is modulation. Modulation in time is equals to frequency shift in frequency by fc, or fc here the carrier frequency. The fc is a carrier frequency which is very high in frequency for modulation to occur. For example, the GSM communication system. GSM is a 2G communication system, which is a global system for mobile communication. Can somebody let me know what is the frequency of the GSM? No issue. So generally, the FC is equals to 900 megahertz for 2G we use. For 3G we use 2.4 gigahertz. That's different frequency. 3G, 4G, different. So according to our requirement, we use. So modulation can be represented graphically as a baseband signal. Um, let me take another link, if this link expires because 1 hour is going to complete, so for the problem solving, main problem solving, we have to create another link. So if this link is existing, then no issue. We'll just continue with this link only. Otherwise, if this link expires, then we'll move to other link. So I'm adding in the chat box. This is another link. This is another link if this particular meeting expires. Otherwise, we will just be here only. Okay. So this is all about the modulation and all. So you know about the frequency. The modulation in time domain is just a frequency shift in frequency in the frequency domain. So direct delta function, this one is a property of direct delta function. I'm just moving forward because we need to solve some questions related to this. So we just tell you about some of the properties of the delta function. So unit impulse function is also called the direct delta function, and delta t is equals to 0 if t not equals to 0, otherwise it equals to infinity. At t is equals to 0, we can write like this: delta t, and this is t. If we take another color, then this is infinity, otherwise it is 0, 0, 0, 0. Sorry, for another t is equals to 1, t is equals to 5, any values will we have 0. So it is defined as equals to infinity 0, t is equals to 0, t not equals to 0. So we have the properties of direct delta function. Since we cannot define a infinity value, so the summation of del t is equals to 1. And here the continuous signal is defined so integral is defined 1. So it is called as area under delta function. So this is very interesting property of delta function. The area under delta function is equals to 1. Otherwise, the value at t is equals to 0 is equals to 1, infinity. But otherwise, I told you about the discrete delta function. So in the discrete delta function, we usually don't have any integral and all area. We just have here one value of 1. So discrete one is del n. This is 1. Otherwise it is 0. So del n is equals to 1 if n is equals to 0, 0 if not equals to 0. This is one is discrete and this one is continuous. So we usually multiply that delta function to some of the time domain signals so that we will have a Fourier transform of 1. So if you ask me to calculate the Fourier transform of delta function, let us calculate. The Fourier transform is defined as minus infinity, sorry, x of f. Here the f should be there to infinity xt e ka power minus j 2 pi ft dt, and here xt is equals to del t. So minus infinity to infinity del t e ka power minus j 2 pi ft dt. So we know that this function exists only at t is equals to 0, right? So we are putting that value at t is equals to 0. So minus infinity to infinity del t, this 0 dt minus infinity to infinity delta t dt is equals to 1. So we know that we get to know that x f of delta t is equals to 1. And we will use this property later. So moving ahead, and this property is very important. What if we multiply a delta function in the time domain of any signal. So it's simply this function is zero is one only at t is equals to zero. So phi then it will be simply phi of zero egg del t. So if you multiply any signal, for example xt, then del t, that equals to x of zero, then del t. So this is a property of a delta function. And what if you just shift the delta function? So this is also very important. So if you're shifting the delta function, then this is equals to 1 only if t is equals to t naught, isn't it? So del of t naught, then del t minus t naught. So what is the Fourier transform of unit impulse? So it is equals to 1, I told you earlier. So duality property of Fourier transform and introduction to linear time invariant system. So Fourier transform has the property of duality. Duality means, I'll just let you the formula of duality property. So see, xt Fourier transform xf, then x of t, the Fourier transform of x of minus f. Here, small x and capital F differs duality. So the small x is another function, capital X is another function. So you will apply here the Fourier transform duality principle to sinc function. Sinc function. So just take xt is equals to pulse function, which is equals to p of t. Then p of t, we know that it is t sinc pi pi sinc of t. Then you calculate here sinc tf t, that is a pulse function. So the inverse Fourier transform of sinc function is pulse function. So principle of duality is this. The sir has taken the example of this as a pulse function. The linear time invariant system, the LTI system has the three properties: linear, time invariant, and superposition. So linearity follows if this follows. I'll share you these slides with you so that you will have the understanding what I told you in the class. So the linear means the superposition and the scaling factor should apply. Otherwise, it would not be linear. And the linearity plus time invariant is equals to LTI system. So time invariant is the students have the problem of time invariant. So I will ask you if xt is equals to uh, t plus 1, whether it is time variant or time invariant. So let us calculate if xt is equals to t plus 1, the xt minus 2 is equals to uh, t minus 2 plus 1, then xt minus 2. Then if we are just the shifting the time to minus 2, the output should also shift the time to minus 2. But here you are shifting the time to minus 1. So this is an example of time variant. So similarly, you can calculate the time variant and time invariant properties. So let us move towards the questions which will help you in solving the uh, assignment questions. So these are all about the basics, whatever which is required and which is being taught in your week 1. So so Let us move towards the related questions. Let us solve one by one. I hope you all will be excited. So if you have any query, please do raise your hand in the Google Meet, and please try to ask in the chat box. Otherwise, I can also listen through your voice. The first question is, let us write the question in black. The energy of a power signal. Can somebody answer or let me know how to solve this question? No, sure, I'll solve. First of all, what is power signal? The power signal is a signal whose power is finite, right? And energy can be defined as, if we take a power signal as continuous signal, then minus infinity to infinity mod of xt square dt. Here we are just saying as xt as power signal. On top of it, we have to calculate the energy of the signal. Then a power signal is a periodic in nature, we know that. So suppose, let us not take a simple function. So here after t by 2 and t. So here after t, this is repeating. This is t. So period of xt is equals to t here. So period of xt is equals to t here. And we know t will repeat till end. So t tends to infinity. But here we are calculating averaging over only over a single time period, which is t. So power is equals to 1 by t, sorry, limit t tends to infinity, 1 by t, 1 by t minus t by 2, say t by 2 mod of xt square dt. If you just square this signal and calculate using this formula, how will you get the value? You will get some value here. Let us split this function. Equation 1, energy, equation 1. So minus infinity to infinity mod of xt square dt. You will get value for 1t, suppose 0 to t. If we are just, actually not, it is infinity in domain. So suppose take value greater than 0. So 0 to t by 2 mod of xt square dt. Then 0, then what is this? T by 2, 3t by 2. T say t to 3t by 2 mod of xt square dt. Then again t 2t say 2t plus t by 2 mod of xt square dt. And this will continue and for negative also. So here you will get suppose value of x1, sorry, a, here you will get the value of b, here you will get the value of c, then a plus b plus c plus some value, and this is for infinity time. So energy of a power signal is equals to infinity. So the answer for this question is infinity. Now let us take the second question. How you can calculate the second question. So let us first read the second question. And these all questions are very related to your assignment questions, similar questions, and so that you can able to solve the assignment questions very well. So with a proper understanding as well, because understanding is very needed for your knowledge. So consider the Fourier series of a signal xt with the fundamental frequency f naught is equals to 1 by t. The coefficient cl in the Fourier series corresponding to the term power e to power 2 pi l f naught t is given as. How you can calculate this? So, can somebody answer me this question? Magnify the screen. Okay, sure. This is an interactive live session, so interaction should happen. I'll request you to please ask your queries. These are all related to whatever I just brush up your concepts and all. A. Okay. Are you sure A it is A? The answer is not A. Thank you for answering. At least you should have identify your mistakes. So Fourier series is represented as summation of minus infinity to infinity L is equals to minus infinity to infinity C of L e power j 2 pi L f naught t, which is required for the discrete Fourier series, and which is required for calculating the spectrum of a signal, which is required for calculating the Parseval energy theorem, power theorem. Sorry. Why power? Because here the Fourier series is calculated for a power signal. So the CL is defined as 1 by t minus t by 2 to t by 2 xt e power minus j 2 pi L f naught t. So what should be the answer? The answer should be C. You should remember the negative and the positive sign in your gate exam also. So in order to score good gate score, you should know how to where the negative sign is this and where the positive sign is this. I'm telling you the basic rule where you can get basic understanding how you can think where it is negative or positive. So in every Fourier series, in every discrete Fourier transform, in every bandwidth calculation, you require negative sign because negative is required for calculating with the integral sign. The negative comes with the integral sign. So here the CL here with the is coming with the integral sign. The integral sign with the negative sign. So what should be the answer? It should be the C. We'll have similar questions in your assignments. So question 2 solution. Answer is C, where CL is equals to 1 by t minus t by 2 to t by 2 e to power, sorry, xt e to power minus j 2 pi f lt dt. So it is also called exponential Fourier series coefficient. So let us solve next question. So what is the answer? A Fourier series can be found for continuous time periodic signal, discrete time periodic signals, continuous time periodic signals, discrete time periodic signals. Very good, Sangojni Tejasvi. Very good. So it is defined for continuous discrete and periodic signal. Why? Because Fourier series is written as the summation. Wherever the summation is there, you just tell it is discrete. And CL, sorry, my pen is not okay. I think. So Fourier series CL e power j 2 pi f t f naught, sorry, f naught t 2 pi L f naught t. So here the discrete comes. So discrete and periodic. Why? Because here you are just getting the harmonics of of f naught. What is the harmonics? Harmonics means the frequency, the integral multiplication of f naught. F naught is the fundamental frequency of this particular signal xt. Then the harmonics, you are representing it in the harmonics of the fundamental frequency f naught. So you are just calculating it in the form of Fourier series. Now consider the complex signal xt is equals to 1 divided by 2 plus jt, where t is defined from minus infinity to infinity. What will be the energy of the signal? Please solve in your question in your book and let me know the answer. I am also solving here, but I want you to solve and answer. NS Murthy Sharma, pi by 2. Let us wait for some other answers. And this is the live interactive session. You can ask your queries, you can solve your questions, you can just let us know your doubts. You can just let me know. So only one answer is there, pi by 2. Can I know other answers? Is it the pi by 2 or something else? Okay, okay. Two people have answered as pi by 2. Nice. So let us solve this question. So solution 4, here we will solve. Solution 4. Xt is equals to 1 by 2 plus, what is that? Jt, where t defines from minus infinity to infinity, and you are asked to find this energy of a signal, xt. What? So first of all, the question asks why only here the energy of a signal is defined, because it is not a periodic signal. It is not a periodic signal. The for other signals we define as energy. So energy is equals to minus infinity. Why I am taking integration? Because it here it is a t for the continuous signal. It is continuous signal. Otherwise, I will must have taken summation. Wherever the summation comes, we do just take the information that it is a discrete signal. So mod of xt square dt. Here I can also write integration of minus infinity to xt x conjugate of t dt. The conjugate here, why? Because it is the complex periodic, it's complex signal, so not periodic, complex signal. So you can also write in the this form. So minus infinity to infinity, 1 by 2 plus jt to 1 by 2 minus jt dt. Minus infinity to infinity, 1 upon 4 plus t square dt. So this is t square dt. So since it is a even function, what is even function? I will tell you. Xt is equals to x of minus t, because here you can see xt is equals to 1 by 4 plus t square, or x minus t is also equals to 1 by 4 t square. Then we can write 2 into 0 to infinity. We can split the integral into two parts because it is a even function. Even function property. 1 by 4 plus t square dt, and then 0 to infinity 1 upon, let us take 4 out, 1 plus t square by 4 dt, then 2, 0 to infinity 4 came here, then 1 plus t by 2 square dt. And can I be told what is the inverse integration of this one? It is a direct formula. Okay, no issue. This is the inverse integration of tan inverse t by 2, because tan inverse x ka integration will be 1 upon 1 plus x square. So using this, what you will get? Tan inverse t by 2, 0 to infinity, and 1 by 2 tan inverse infinity minus tan inverse 0, 1 by 2. Sorry, I'm getting, I think, something wrong. Tan inverse infinity, 2 plus j. I think the option is wrong. The answer is pi by 2 minus 0. Answer is pi by 4. The answer is pi by 4. The first option should be pi by 4, I think. Yeah. Just going to the calculation again. Um, yeah, somebody has raised voice. 2. Sorry. That it 2. Okay, okay. It x by a will be, so tan inverse x by a will be a into 1 plus x square by a square. So this the formula should come. Okay, okay. So here the 2 will be coming. So to 2 will be coming, and then 2 into 2, then pi by 2. Okay, the answer is pi by 2 only. Thank you. Thank you for pointing it out. Actually, I missed it. So moving to the next question. So what is the next question? Here the next question comes. The power of energy signal. What should be the power of energy signal? The energy of a power signal we calculate it as infinity, right? Zero. Yeah, zero. Can you explain zero uh, by speaking it out? Answer will be zero. I want somebody has answered this as, yeah, hello. Please speak. Murthy Sharma. Huh? Yes, Murthy Sharma. Yes, Ashwini. No. You are asking, no, here the question is a power of energy signal. The energy signal is not periodic, right? If energy of a energy signal is defined and energy is not a periodic, then yeah, you can say energy by infinity is equals to zero because the power is defined as the energy by time. So time here, the infinity for energy signal is defined for the infinity, though infinity is equals to zero. So here you can calculate the zero. So Ashwini, your doubt is clear of what you are asking. Can you please repeat? Yeah, you did clear now. Okay. And NS Murthy Sharma, can you please repeat your you have raised your voice hand. Please magnify this. For sure. I will uh, I will definitely share this PDF or the PPT format of all this requirements of all these documents so that you can refer it at any point. And then in the next slides, I will try to use a proper font for the question so that everyone should recognize it properly. So the power of energy signal is zero. Thank you for answering, KG Sharma sir, KG Krishna sir. So power, let us make it, power is equals to energy by time. Here the time tends to infinity, so power tends to zero. Here the tends to is not equals to equal to. Okay. So this is very nice question. I would like that if somebody solve, or then I'll try to correct, or not correct. So I'm giving the time. Can you please solve this question? Question number 6. Consider periodic signal xt with a time period of a t naught and the Fourier series given as xt is equals to in summation of t k is equals to minus infinity to infinity c k e power j 2 pi k f naught t. The Parseval theorem states that. What should be the answer? Okay. And Smriti Sharma. Okay, okay. The answer should be C. How the answer should be C? Because we are calculating the power of a signal in one hand, LHS, and which is we are equating it with respect to the magnitude sum, square sum of the exponential Fourier series coefficient. And this I have solved. Answer is C. Sol Solution is in teaching part. Prerequisites. I explained this one because this is very important. Parseval power theorem. So, so this question is very good. So I hope it is visible to all. Consider a trigonometric series X representation of a periodic signal xt with a fundamental frequency f naught given as this one. The coefficients b and are written as. How can we write the b naught? You might be wondering how it is written like this. So, okay. Is it the answer is A? Can somebody please uh, correct whether the answer is A or not? So Anis Murthy Sharma is saying that it is answer is A. Okay, so he's very correct and answer is A. So how one can solve this question? So let us solve this one. Here I'm solving here in side only. So the Fourier series. The trigonometric representation means the harmonics of the fundamental frequency. So Fourier series is represented as ck e to the power j 2 pi k f naught t, which can also be written as a naught in the trigonometric form, an cos 2 pi n f naught t summation plus summation bn sine 2 pi n f naught t. And this one is the even part. I'll try to use different color. Even, and this one is odd part. So the coefficient bn you are required to calculate. First of all, by looking at any Fourier series expansion, we should be able to calculate the period of a signal. What will be the period of a signal? What will be the period of a signal? Xt. Okay, no answer, no issue. The period of a signal xt will be, I told you, this one is the omega, and the period t is equals to 2 pi by omega. So 2 pi f naught. So here 1 by f naught is the period. Okay. So 1 by f naught is the period of a signal. So Bn can be calculated as or minus t by 2 to t by 2 x t sine 2 pi n f naught t. So here we can write is minus 1 by 2 f naught, 1 by 2 f naught, xt you can write, well, write in a better way. Bn is equals to minus 1 by 2 f naught, 1 by 2 f naught, or xt is written as an plus summation of n is equals to 1 to infinity an cos 2 pi n f naught t plus summation of n is equals to 1 to infinity bn cos sine 2 pi f naught t uh, multiplication of sine 2 pi n f naught t. So you just remember this formula for calculating bn. And for an also I'm telling you minus infinity to minus t by 2 to t by 2 xt cos 2 pi n f naught t. And you can get this formula using the exponential Fourier series. Exponential Fourier series formula. So let us try to solve this. Bn is equals to minus 1 by 2 f naught, 1 by 2 f naught. Okay, I'm trying to add it now. F then an sine 2 pi n f naught t plus n is equals to infinity an cos 2 pi n f naught t sine 2 pi n f naught t plus summation is equals to 1 to infinity bn sine square 2 pi n of naught t dt. Where a zero. Huh. Okay, yeah, a0 should be there because I'm just substituting for xt. So here you know that the integration of a periodic signal of a periodic signal sine t from minus t by 2 to t by 2 will be 0. Here the term will be 0. Similarly, the term there is it will also be 0 because it will calculate it as the summation of this one cos 2 pi n f naught t and sine 2 pi n f naught t. And if you further simplify it, then it will also be 0. Why it will be 0? Because here you can see sine 2a is equals to what? 2 sine a cos a. So here, if you just simplify it in the terms of a sine 2a, then the summation over a period of a sine function is equals to 0. The only term left is this one. So bn is equals to minus 1 by 2 f naught y 1 by 2 f naught summation of n is equals to 1 to infinity bn sine square 2 pi n f naught t dt. So the bn will be um, so here you can calculate uh, bn minus 1 by 2 f naught. So 1 by 2 f naught is equals to sine square 2 pi n f naught t dt. So bn and how one can write sine square 2 f naught t 1 minus cos 2 pi sorry 1 minus cos 4 pi n f naught t divided by 2 into dt and minus 1 by 2 f naught and 1 by 2 f naught and here it is bn 1 by 2 f naught. So um, so I'm trying to here the bn it should not be. I'm trying to calculate minus trying to get the value of bn. So t by 2 to t by 2 xt sine 2 pi n f naught t dt. So here this value is equals to this one. So here this value is equals to this one. This value is equals to this one. So how you can write the Bn? Bn is equals to 2f naught minus t by 2 to t by 2 xt sine 2 pi n f naught t. So I was calculating this function for calculating the Bn. So how it will be? 2f naught minus 1 by 2f naught 1 by 2f naught xt sine 2 pi n f naught t dt. So Bn is equals to this one. So if we try to match the answer will be this one. Why I have focused about this function? Because this function is given in the option, as well as the Bn should relate in the function as a function of sine. So after calculating this, and this is equal to this particular function is equals to 2f naught integration of 2f naught Bn. Sorry, what is the calculation? 1 by 2f naught. So here 1 by 2f naught into Bn. So Bn will be 2f naught into this one. The answer will be 1. I hope everybody get the answer. So I'm repeating this. First, I try to calculate the value of this. The value of this, I have further simplified it. After further simplifying, the two terms vanished. The only terms left is this one, third term. And the third term, if we further calculate it, sine square 1 minus cos 4 pi n f naught t divided by 2 into dt, then we calculate is 1 by 2 f naught. And then 1 by 2 f naught, then bn, we just try to uh, multiply 2f 2 by into 2 f naught, then we will get the bn. So moving to the next question, which is the question number 8. The Fourier transform of the signal pt pulse function t for mod of t less than equals to t by 2 and 0 otherwise. What is this? What is the answer? Okay, and it's more. Okay, nice, nice. So two of the students have answered as C. So they have answered as very correctly because this is solved in the lecture. The question is P of t is equals to 1 for mod of t less than equals to t by 2. So we can write, I can say this implies t is less than equals to t by 2 and t greater than equals to minus t by 2. So pt of t, t. So here it is 1. So after calculating the Fourier transform of pt of t is equals to pt of f is equals to minus infinity to infinity. This is t by 2. This is minus t by 2. pt of t dt. Sorry. Here, what it will be? E to power minus j 2 pi f naught t dt. So, what it will be? 2 pi ft. Sorry, f naught no. Here, no, there's no fundamental of any periodic signal or non-periodic signal. Fourier transform is defined for also a periodic signal. Okay. So, minus infinity. Since the value is already existing for minus t by 2 to t by 2, then here 1 e to power minus j 2 pi f t dt and e to power minus j 2 pi f t, then again e to power minus j 2 pi f minus t by 2 to t by 2, then e to power minus j 2 pi f t by 2 minus j 2 pi f minus j plus 2 pi t by 2. Now you will get the answer as C. Sine j pi f divided by, I think it is pi f, pi ft, pi f. It can also be written as the same function. How? J pi f t divided by pi f t, and you can write here as a t. Then t sinc of j, sorry, j is not there, pi f t, pi f t, pi f t, t sinc of ft. So one can also ask in the form of sinc function. So moving ahead for the next question. This was the eighth question and the ninth question. So ninth question. Direct delta function del t satisfy the property of, what should be the answer? Is it answer 1? KG Krishna. Nice, nice. The answer is fourth, which is area under direct delta function is 1. Why? Why the answer is 1? Because for delta of t, here the t represent it is a continuous signal. Continuous signal. So for the continuous signal, we know that the direct delta function del t should minimize the width. Del t is equals to infinity. Why some people have the problem of got the confusion as del t is equals to infinity? Because del t is equals to infinity only for t is equals to 0. Otherwise, it is 0 for t not equals to 0. So it is infinity, del t, and t. So for this particular continuous function, the area under del t is equals to 1. It is not equals to infinity. So answer is fourth. And for the discrete delta function, the value is 1. Because generally in discrete functions, we define as the discrete values, not as an infinity value. Because discrete function is all itself a discrete one. And the continuous function can be defined for the infinity value. And it is a definition of direct delta function. You cannot deny this definition. So the answer is fourth. So let us solve this easy question. For any signal um, phi t, please clarify Fourier series found for CTP is not. CTP is, what do you mean by CTP? KG Krishna has answered as continuous to. Yes, we can calculate is for Fourier transform for continuous periodic signal. Fourier transform is defined for a continuous signal. But how will you calculate the continuous? Let us take this topic. Eighth question, ma'am. Okay. Eighth question. Let us first finish this 10th question, then continuous time periodic question, then eighth question. So this 10th question, the answer will be B. Why the answer will be B? Because if we calculate this one minus infinity to infinity phi of t delta t dt, then we know that delta t exists only when t is equals to 0. Infinity when t is equals to 0. Otherwise it is 0. So if we put the value as phi of 0, this equation 1, equation 1 minus infinity to infinity phi of 0 delta t dt, then this is a constant. So it will come out minus infinity to infinity delta t dt, and it will be 1. So phi of 0. Okay, I'll repeat the question 8. Okay. So where is their doubt? You might have the doubt of this function, right? Okay, repeating the question means let us repeat this question. So Fourier transform of pulse function, you can define using this formula. Sanjogi, please let me know if you are having any problem in between. Okay, so you can define using this formula, and pt is equals to 1 only for t minus 2 to t by 2. So here I have written as 1. So e power minus j 2 pi ft. Then how we can integrate it? So integration of this one is e power minus j 2 pi ft divided by by minus j 2 pi f. So minus t by 2 t by 2. And you might have come late in the class because I have defined this how it is equal to this one. But again, I'm repeating it. You know, sine t. How you can write the sine t in the form of exponential part? It is jt minus e power minus jt divided by 2j. Okay. So how you can write this? So if you take 2j and this part, then it will be minus sine pi f t. It is j by 2 and d by 2. So pi f t and divided by minus j 2 pi f. So here this part will cancel and you will get sine pi f t divided by pi f. And this is equals to sine pi f t divided by j. Sorry, j will not come here. Sine pi f t divided by pi f t. And if we write this in the form of sinc function, then pi will be there. If you don't able to understand this, then I'll let you know to the base Fourier transform of this function, because continuous whether the Fourier transform can be defined for continuous periodic signal or not, I'm having some doubt. Correlation. No, no, no. Fourier series exists only for periodic signal. Fourier transform exists for a periodic continuous signal. Fourier series. What is Fourier series? Fourier series is is a representation of a discrete periodic signal. We are representing it in a form of harmonics of a periodic signal, right? Because f naught here, the f naught was the fundamental frequency, which is the period of a periodic frequency of a signal, and f naught is equals to 1 by t, where t is the time period of a signal. So the Fourier series is defined for a periodic signal, whereas a Fourier transform is defined for a periodic continuous signal. The question now arises whether it can be defined for continuous time periodic signal. So yes, we can define it for the continuous time periodic signal, because the formula, if we know the formula of the Fourier transform, I'll write in the Fourier transform part only. KG Krishna, your doubt got cleared or what? Yeah, 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 yeah. Yes. So if we go to the basics of Fourier transform, where it is. We generally don't define it for the periodic signal because it will repeat till a period. It will repeat till a period. So for that concept, we call it as a discrete Fourier transform for a continuous periodic signal. So later in the course, sir will deal with this part. Otherwise, the Fourier transform is defined for the continuous aperiodic signal. Mm, mm. Yeah, yeah, yeah. DTFT and DFT will come later in the part when you are having here the input. See, here you are having the input and output. The input, if the continuous, and aperiodic, then the output will be what? Fourier transform, continuous time Fourier transform, continuous time Fourier transform, CTFT. And the output is also continuous and aperiodic. Where if you have continuous and periodic, then you will have Fourier series because it is written as uh, Fourier series because and the output is discrete and periodic. The output is discrete and periodic. The formula here is ck e to the power j 2 pi k f naught t. Here f naught is the periodic frequency. Here in this formula we don't have any periodic frequency or anything because we're just defining it for the continuous signal minus infinity to infinity xt e power minus j 2 pi ft dt. Here no f naught is there. So continuous and periodic the Fourier series comes. And if you the question is arises if we can define the Fourier transform, then we can define the Fourier transform. The answer will be in the terms of Fourier series. It won't be Fourier transform. So this input output relation is very important. And Murthy, hello, Anas Murthy. Yeah, can you please repeat your query? Hello, I'm waiting. Okay, then I hope this doubt is clear for the Fourier series and Fourier transform. And this the Tejasvi, your doubt I'll cover here. If you are not getting this point, then here I have mentioned it for the question number 8. So I'm again mentioning it for the question number 8. Solution to question 8. So answer was this uh, sine pi ft divided by pi f. Uh, okay. Okay. Uh, yes. Yeah, true. It is only a representation, it is not a transformation. So for the periodic signal, we are representing in the form of the fundamental frequency, in the form of harmonics of the fundamental frequency, so that it will be helpful for calculating the power using Parseval power theorem. And yeah, yes. Yeah. Okay, then I think the live session is has to end now because the time is I think 7:56 or 7:53. I hope you all enjoy. And those who are not able to join the session, I have posted my YouTube link there. And you can also mail to me. I'll post my mail ID also here. So, my YouTube link, I'll please watch this recorded session, this um, session, YouTube link. And stay tuned in this class and stay tuned to this course. You will learn so many things about the communication system. And for if you are going for a communication industry, you should have a deeper knowledge of these things. And for the gate aspirants, you also have you will also get to know many things about this. So thank you and all the best. I'll stop sharing the screen now.